Welcome to your exciting journey into NoSQL databases. Let's dive right in. What is a NoSQL database? NoSQL means not only SQL, it's a revolutionary approach to storing and managing data that breaks free from traditional table structures. Unlike SQL databases with rigid rows and columns, NoSQL databases are flexible, scalable, and perfect for modern applications dealing with massive amounts of diverse data. Now, let's look at our analogy section. Think of it like SQL is like a filing cabinet with fixed folders, while NoSQL is like a magical storage room that adapts its shape to fit whatever you put in. And here's our remember section. Remember, NoSQL equals flexibility plus speed plus scale. Now, why was NoSQL introduced? The digital explosion demanded something bigger and better. Traditional SQL databases couldn't handle big data with millions of users and billions of records, the speed needed for lightning-fast read and write operations, the variety of images, videos, social media posts, and IoT data, and global scale for applications spanning continents. Let's check our real-world example. Imagine Facebook trying to store billions of posts, photos, and videos in a traditional spreadsheet. Impossible. NoSQL made social media possible. Here's our key point section. Key point. NoSQL was born from necessity. The internet age needed database superpowers. Let's explore the battle between SQL and NoSQL. Choose your database superpower. What are the main differences between SQL and NoSQL? SQL databases are structured, ACID compliant, and handle complex relationships. NoSQL databases have flexible schema, are horizontally scalable, and use eventual consistency. Now, let's look at our visual memory section. Visual memory. SQL equals rigid table. NoSQL equals flexible JSON. When should you use NoSQL over RDBMS? Choose NoSQL when you need rapid development for quick prototyping and iteration, massive scale for millions of users and terabytes of data, flexible data with varying document structures, real-time apps like gaming, chat, and live streaming, and cloud-first architecture distributed across multiple servers. Here's our car analogy section. Car analogy. SQL is like a reliable sedan perfect for daily commute. NoSQL is like a monster truck that handles any terrain, any load. And our rule of thumb section. Rule of thumb. Big, fast, flexible equals NoSQL. Time to pick your perfect database match with NoSQL types. What are the major types of NoSQL databases? There are 4 main types. Key-value stores provide simple key-to-value mapping like Redis and DynamoDB. Document stores handle JSON-like documents like MongoDB and CouchDB. Column family manages wide columns like Cassandra and HBase. Graph databases handle connected relationships like Neo4j and Amazon Neptune. Let's explore our shopping analogy section. Shopping analogy. Key value is like a locker system. Document is like file folders, column is like a spreadsheet on steroids, and graph is like social network connections. Here's our memory trick section. Memory trick. King David can golf. Key value. Document, column, graph. What is eventual consistency in NoSQL? Eventual consistency means data will become consistent across all nodes eventually, not immediately, but soon enough. Instead of waiting for all servers to update simultaneously, which is slow, NoSQL systems update one server first, then gradually sync with others. Now for our WhatsApp example section. WhatsApp example. When you send a message, it shows sent immediately, then delivered when it reaches the server, then read when your friend sees it. That's eventual consistency. And our trade-off section. Trade-off. Speed now versus perfect consistency later. Let's discover the science behind NoSQL magic with BASE and CAP. What does BASE stand for in NoSQL? BASE is NoSQL's guiding principle. B stands for basically available, meaning the system remains operational. S stands for soft state, meaning data may change over time. E stands for eventual consistency, meaning it will be consistent eventually. Here's our store analogy section. Store analogy. A 24/7 convenience store that's always available, where shelves get restocked throughout the day as soft state and inventory becomes accurate by morning as eventual consistency. Let's check our remember section. Remember, Base equals flexible and fast. Acid equals strict and slow. What is the CAP theorem? CAP theorem states you can only choose 2 out of 3. C stands for consistency, where all nodes see the same data. A stands for availability, where the system remains operational. P stands for partition tolerance, where it works despite network failures. Most NoSQL databases choose AP, available plus partition tolerant over consistency, prioritizing speed and uptime. Now our pizza delivery analogy section. Pizza delivery, you can have it fast, cheap, or high quality, but only pick 2. CAP theorem works the same way for databases. And our NoSQL choice section. NoSQL choice usually picks available plus partition tolerant. Discover why everyone's making the switch to NoSQL superpowers. Can NoSQL databases be ACID compliant? Surprising answer. Some can. Modern NoSQL databases offer ACID compliance when needed. MongoDB provides ACID transactions within single documents. Amazon DynamoDB offers ACID for single-item operations. Google Cloud Firestore has ACID transactions. FaunaDB is fully ACID compliant. Let's look at our sports car analogy section. Sports car. Modern NoSQL is like a sports car with safety features. You get speed and reliability when you need it. Here's our best of both section. Best of both. Choose your consistency level per operation. What are the advantages of NoSQL? Scalability lets you handle millions of users effortlessly. Flexibility allows you to store any data format and change schema anytime. Performance provides lightning-fast reads and writes. Cost-effective means running on commodity hardware. Developer-friendly offers a natural fit for modern programming. Now our garden analogy section. Garden analogy. SQL is like a formal Japanese garden that's beautiful but rigid. NoSQL is like a wild meadow that grows naturally and adapts to environment. And our bottom line section. Bottom line. NoSQL equals scale plus speed plus simplicity. Let's explore the simplest database superpower, key-value stores. What is a key-value store in NoSQL? A key-value store is the simplest NoSQL database. It's like a giant dictionary where you store data using a unique key to find it instantly. Here's our memory trick section. Memory trick. Key value equals your phone's contact list, where name leads to phone number. What are examples and use cases of key-value stores? Popular examples include Redis, which is an in-memory speed daemon, Amazon DynamoDB as a fully managed cloud solution, and RYAC, which is highly distributed and fault-tolerant. Perfect use cases are session management for login tokens, caching to store frequently accessed data, shopping carts, user preferences, and real-time recommendations. Let's check our vending machine analogy section. Vending machine. Insert coin as key, get snack as value. Instant, simple, no questions asked. Welcome to your data's natural home with document stores. What is a document-oriented NoSQL database? Document stores save data as documents like JSON files instead of rigid table rows. Each document can have different fields and structures. Here's our file cabinet analogy section. File cabinet. Each document is like a complete file folder containing all info about one person or thing, organized naturally. Let's explore MongoDB and BSON magic. MongoDB is the king of document databases. It stores data in BSON, binary JSON format for lightning-fast performance. BSON benefits include faster parsing than regular JSON, support for more data types like dates and binary, compact storage, and native support for arrays and nested objects. Now our shipping analogy section. Shipping. JSON is like packing items in a box. BSON is like vacuum sealing them. Same stuff, way more efficient. And our pro tip section. Pro tip. MongoDB equals JSON for developers, BSON for performance. Learn to find your data in milliseconds with document mastery. How are documents stored and retrieved? Documents are stored in collections like folders and retrieved using flexible queries that can search any field or combination of fields. Here's our Power Move section. Power Move. Query any field without predefined structure. How do indexes work in document stores? Indexes are like book indexes. They create shortcuts to find data instantly without scanning every document. Types of indexes include single-field index on one field like name, compound index on multiple fields, text for full-text search capabilities, and geospatial for location-based queries. Let's check our library analogy section. Library. Without index equals search every book page by page. With index equals jump straight to the right shelf and book. And our speed secret section. Speed secret. Good indexes equal 1,000 times faster queries. Let's explore spreadsheets on steroids with column family stores. What is a column family NoSQL database? Column family stores organize data in column families like super-wide spreadsheets where each row can have different columns, perfect for big data analytics. Here's our Excel evolution analogy section. Excel evolution. Imagine Excel sheets where each row can have completely different columns. That's column family power. Let's discover Cassandra and super columns. Apache Cassandra is the champion of column family databases, designed to handle massive scale across multiple data centers. Super column is a column that contains other columns. Think of it as a folder containing files. Perfect use cases include time series data from IoT sensors and logs, social media feeds, product catalogs, financial transactions, and any big data analytics. And finally, our Cassandra's superpower section. Cassandra's superpower, linear scalability. Double your servers, double your performance. That concludes our exciting journey through NoSQL databases. You've now mastered the fundamentals and are ready to tackle any NoSQL interview question with confidence.